Okay, so good morning again, everybody. With respect to the new change in the exam thing, right? I just want to clarify that a little bit. Okay, just now, let me just get it. So I see some people trying to chat. Okay, right. The new structure of the exam is a multiple choice paper and your SPE. Now, for the private candidate, the students who are not full-time students, like for example, the Wednesday class as well as the Saturday class, you all are required to write something called a paper 3. Now, the paper 3 is an alternative to the SBE. However, I'm not sure how they are going to do that paper 3, right? Because as far as I know, that's like a mini paper 2. And probably might have like 10 people in a room or something, or you all might have it online. With respect to multiple choice, a lot of people are of the opinion that CXC will just bring a normal multiple choice and give you all that to do. Now, obviously, they are aware that students have copies of multiple choice papers and whatnot. And because of that, I strongly believe, and when I believe something, it kind of like happen now, because based on trends and whatnot, and based on how they structure the message that they have to the public, I think that they are going to have like a paper 2 question. So they might have a normal regular paper 2 question and they might have multiple answers for it, right? It will not, I don't think it will be a regular multiple choice paper, like what you all accustomed getting. It could just be you never know. I could just have a wrong feeling, but it could just be a regular multiple choice. But again, you don't want to chance that, right? And a lot of students are of the opinion that they will just practice with the multiple choice papers and the question is going to repeat, and they just have to sit down and write the exam, and that's it. What if
all the questions?
Yeah, what if CXC decides to bring new questions? Because I mean, everybody's going to have access to multiple papers and everybody's going to be practicing. So what if they decide to change up the exam a little bit, and you all would have not studied anything, just do past paper practice with the multiple choice, and then when you watch the paper, only like 3 or 4 questions repeat, and you don't know how you didn't study, so you don't have the knowledge and whatnot, right? And that's why a lot of students, they are not coming to class online and they are skipping the classes and whatnot because they believe that the exam is going to be multiple choice, and they already do it in the SBA because majority of full-time students, they got 50% and over, right? So they already have a advantage over the students who are doing the paper 3. However, with the multiple choice, nobody is sure as to how the format will be. And it will also be the first time that CXC will be issuing an online multiple choice exam as well, because I believe it will be online. I don't think they could have it as a physical exam. So you never know how the questions will come. And like I said, this is about bring a paper question, and all you have to do is choose one of the answers there, and they could bring several answers. So let's just say, like let me just use this example here. For instance, let's say I ask you a question like this, right? Don't get confused with the word, right? I don't expect you to know what it means because I didn't teach you yet. Let's say this is the paper 2 question they ask you, right? And piece of it requires you to find the determinant, which is 2 in this case, and then there are like 3 other steps, right? So they could give you this as A, this could be B, and this could be C. And you just go and find the first part, and this could be A, and you select, okay, A. You understand? So this is probably how they could bring it as well. Give you a regular paper 2 question and give you pieces of the answers and confuse you. But only the students who actually study will know the final answer is a half multiplied by this new matrix. I hope you all understand what I'm trying to say. I hope I didn't confuse anybody. But yeah, the point I'm trying to make is that do not leave any stone unturned. Study everything. Practice with the paper 2 as well as the paper 1. And I was advising you all for the past month and more to go by Matthew downstairs in admin office in CTS and purchase the multiple choice booklet from him, right? I will try my best to send some for you all online, not online on the Google Drive, but there's only so much I could do as well, right? You have to practice, and with this time that you all have, everybody has this free time now with the quarantine situation. Please use this time wisely to catch up on your maths, to practice your multiple choice questions, to practice your paper 2, to brush up on certain parts of the question, of the syllabus that is giving you problems, etc. Do not let this time go to waste, because at the end of the day, you want to write your maths exam and you want to get a 1. The exam is just a month or 2 away. We know one, March, April, May, June. Like, to be quite honest, I don't even know when the exam gonna be. I think it's like in July, I think. So that's 4 months away, right? Oh, I think it's in May, June. Okay, I can't even remember. I know Linda was seeing it. I have it right on somewhere. But yeah.
When is the exam?
I'm not quite sure exactly when it's the date. TXT didn't say, okay, the maths exam is this date, but they just give us a time. But I can't remember. I have the memo somewhere right now. I have it. I can't remember where I have it, but I will tell you another time. But yeah, use this time wisely to catch up on your maths. Yes, I know some of you all are adults and you have families and whatnot, but please make the sacrifice, because there's only one time you want to write this exam. You don't want to come back here next year again and be writing the exam, and now you have a better chance of passing the exam with the multiple choice, you know? So you don't want to let this opportunity pass you by, right? Because with the paper 3 and the multiple choice, your chances of actually passing the maths exam has increased significantly, right? So this is an easy way. You're probably, although we have a crisis right now, it's kind of a blessing in the sense of the exam that you all don't have to write a paper 2, right? So please take advantage of it and study hard as you can, and you know, try to pass the exam and whatnot. Okay, so let's get started with this handout. It's a pretty straightforward handout, but I'll explain it to you all. Let me see if I can get this red pointer. Okay, so a matrix is an arrangement of elements in rows and columns enclosed by a pair of curved, sometimes square brackets. So the brackets can be curved or it can be literally square, like I don't think I have any here, but we'll come across it sometime, right? So again, it's an arrangement of elements in rows and columns enclosed by a pair of curved brackets, sometimes curly brackets, right? Sorry, square brackets. So for example, we have A, B, C, D, we have A, B, C, D, E, F, we have A, B, we have A, B here again. And of course, A, B, C, D, E, and F are constants or numbers, all right? These will not be looking like this. They'll have actually numbers in it. So understand this, you need to understand what is a row and what is a column. So a row runs from left to right. So a row goes across. Rows go across, right? Column runs from top to bottom. So this is a column here, this is a column here, a column, a column, a column. Just think of your margin column in your notebook, and that's an easy way to remember it. Now, you need to understand the order of a matrix. This is very, very important. So the order of a matrix is the number of rows multiplied by the number of columns of the matrix. So that is row by column, okay? So let's see what I mean here. So for example, we have a row going across and we have a column coming down. So we have 2 rows and we have 2 columns, right? So the formula is row by column. So that's why I have R by C. So it's 2 rows multiplied by 2 columns. So it's 2 by 2. And therefore, that makes this a 2 by 2 matrix. Anybody have any questions so far? Anybody?
No.
No? All right. If you all want to get in contact with me, you have to put on your mic, right? Because the chat not coming up when I'm on full screen here. Okay?
Actually, I have one question. In this paper 1 that we getting, would they like bring questions from the paper 2 and put it in the paper 1?
You can see that?
The new paper 1 we getting, would they bring questions from the paper 2 and put it in the paper 1 and like let us use calculator and stuff?
Actually, I have no clue what they could possibly do. What they could possibly do. So I really can't answer that. You never could tell. As I was saying at the beginning, you never know if they can modify a paper 2 question and put it in multiple choice form and give it to you all to do.
Okay.
Yeah. Okay. So now that nobody has any questions with respect to the order of a matrix,
So I have one. You can repeat it again, please.
sure, no problem. So the order of a matrix is the number of rows multiplied by number of columns. In this case, we have two rows, as you can see, R represents rows, right? We have two rows going across, and we have two columns coming down. So this is row by column, which is 2 by 2, and therefore that makes this a 2 by 2 matrix. Yeah?
Okay, thanks.
Yeah. So this one, we have two rows going across, and we have three columns coming down. So again, the formula is row by column. So that makes this a 2 by 3 matrix. Any questions so far? I'll repeat it again. There are two rows and three columns. 1, 2, 3. So that makes this a 2 by 3 matrix. This is the formula again, row by column. That is to determine the order of a matrix. Example 2, we have 1, 2, 3 rows and 1, 2, 3 columns. So row by column, that makes this a 3 by 3 matrix. Yeah? And because this is a 3 by 3 matrix, this means that this is a square matrix, right? And literally 3 sides, well, 3, 3, 3, 3, 3, right? So it forms a square, so this is a square matrix. This is a rectangular matrix, etc. All right? Any questions? No? Okay. Let's look at the types of matrix. Sorry, types of matrices. The first one, and please people, remember the different types of matrix. They are very important. The first one is a row matrix. A row matrix is a matrix having only one row. So for example, we have 2, 4, 3, 6, 9. So these are row matrix. There are no columns. Yeah? Sorry, there are columns, but there's only one row. You all following, right? So they have columns, but there is only one row. Any questions so far? Okay. A column matrix. A column matrix is a matrix having only one column. So it has one column. It comes down this way. Yeah? Other one is a null matrix. A null matrix is a matrix with all its elements being 0. So all of the elements in the matrix, if it's 0, then it's called a null matrix. A square matrix is a matrix that is, sorry, I repeated that. A square matrix is a matrix where the number of rows equal the number of columns. So for example, a 2 by 2 matrix, a 3 by 3 matrix, etc. Right? As I was telling you here, this is a square matrix here. 3 by 3, 2 by 2, 4 by 4, etc. A diagonal matrix. This is a square matrix where all the elements are 0 except the elements in the diagonal. Now, the diagonal runs from the upper left to lower right. Upper left to lower right. It comes down like this. Yeah. So all the elements in the matrix would be 0 except the elements in the diagonal. So you have diagonal having elements being numbers other than 0. Any questions? If you want me to repeat anything, point your mic, you know.
So
Uh-huh.
on the 2 by 2, right?
Mm-hmm.
We have zeros at diagonal. In the 2 by 2, the zeros are diagonal.
There's 2 zeros to point here?
Yeah.
No. Diagonal runs from upper left to lower right. This is diagonal.
Oh.
Yeah.
Okay.
This is diagonal, and every other element in the matrix is 0. Yeah.
Okay, then.
Yeah. So this next matrix here is very important because you all will be using this later down. So identity matrix, or it's called sometimes a unit matrix. So this is a diagonal matrix in which all the elements in the diagonal is equal to 1. So an identity or unit matrix is usually denoted or represented as I, a capital I. So for example, again, all the elements would be 0 and the elements in the diagonal would be 1. So all the elements in the matrix is 0 except the elements in the diagonal, and the element in the diagonal is equal to 1. Once that is the case, then it is referred to as an identity matrix. Anybody need any clarification before I move on? Say no or forever hold your peace.
So I hold up my piece, but please send in this to the group, right?
Of course, as soon as I'm finished the handout, I will definitely send it to you.
Okay, thank you.
Yeah, no problem.
So we're gonna get questions on this, right?
Of course, of course. So,
Don't move. She wanna take down something.
is that some thing for you? Okay.
You didn't send it to me. You sent it to my mother.
Like, wow, we're living in different places, right? Just now, let me see if I can find my camera now to show you how to add matrices.
Don't worry, she gave it to me.
Okay, no problem. So let me see if I can find this camera. Hold on. Can you see my board? Everybody see the whiteboard?
No, sir.
No, sir.
Oh dear. How do I do this? Okay, just a minute.
Great.
All right. So we're gonna deal with addition of matrices, right? Addition of matrices. So for example, if we were given, for example, 1, if A is equal to, let's just say, 5, 4, 12, and 3, and B is equal to, let's just say, 9, 6, 7, 8, and we are asked to find A plus B. This is how we're going about doing it, right? 5 plus 9, so 5 plus 9, 12 plus 6. Okay, let's start back here. And of course, 4 plus 7, and then 3 plus 8. So let's add them up now. 5 plus 9 is how much?
14.
Okay, thank you. 7 and 4 is 11. 12 and 6 is 18. And 3 and 8 is how much?
12. 11.
Now
11.
we know. That's not going to say like an infants. Right. So this is how you add a matrix. Anybody have any questions?
Nope.
No? All right. So I'm gonna put up one for you all to try them. Oh, y'all want to take a screenshot or something?
It recording, sir.
Oh,
So I
true.
take it. That's not the reason.
Take a screenshot, please.
Colleen, it happened. It will be on the YouTube. You don't need to do that.
Yeah, but I don't want to go on YouTube.
Okay, hurry up, Kalim. Hurry up, hurry up.
Just screenshot it.
Yeah, just screenshot it now. You go check it out after. So,
All right.
okay. So I'm gonna give you all one to try now. If this is example 2, x is equal to 17, 3, 21, 9, and y is equal to 9, 18, 6, and 15, find x plus y. So I don't want anybody shouting the answers. I will select somebody to do this for me, okay? The subtraction is just the opposite of addition, right? So I want you all to try this question. I will select somebody.
Negative 21, right?
Right.
And the negative 6. Would you put minus 21 minus 6 or just minus 6?
Just plus it.
Minus 6, but it will turn to a plus.
I know. I just like to put the minus.
Yeah, that's fine. but you could use your calculator just to make sure, because up to now, I mean, I'm a big math teacher and I still use my calculator because I don't trust my brain too much.
Same.
Yeah, I can do any maths on paper, but not in my brain. So that's why I always have this little fella here. Okay, anybody wants to share the answer? Can I call on somebody? I'm going to call on somebody.
Wait, sir, not me. Wait, I'm still doing it.
All right. So Nirvana, I select you to do the to give me the answer, right?
Lol. Rip Nirvana, 2006 to 2020.
Nirvana, you're 14? Okay, Nirvana, you have the answer to share?
Hold on.
So I get 8,
Mm-hmm.
right? And then negative 15
Mm-hmm.
for the row, and the
Same.
underneath part is 4 and negative 6.
Now, one piece wrong.
No?
One piece wrong, I'll show you. So
It's 11.
it's 17 minus 9, then negative 21 minus negative 6, and then 3 take away negative 8, and then 9 take away 15, right? And of course, 17 take away 9 is 8. This will turn into a plus, right? And of course, 3 plus 8 is 11, not 5. And then negative 21, this will turn into a plus. Negative and negative is a positive. So negative 21 plus 6, this will give us negative 15. And then, of course, 9 take away 15 is negative 6. And this is V take away G.
Yes, sir.
Yeah. Okay, so let me give you all one more to try.
Sir, that's exactly what I said.
No, you said 4.
Yeah, you said
Wait,
4.
I didn't say. Oh, shucks. Okay, my bad.
Yeah. That's 4. So let's look at number 2. If A is equal to negative 13, 18, 14, negative 6, and B is equal to negative 3, negative 21, 6, and negative 14, find A minus B. Let me just call on some people just to make sure that they're here. Anissa, are you here? You can just raise your hand. Or you can point your mic and say hello. Okay. JL, are you here?
Yes, sir. So, I'm so confused with this, but, like, I don't really know how to do it properly. Never really understood how to do it properly.
Okay. Well, follow from this example, right? I'll do it very slowly for you, and hopefully you'll get it right.
Okay.
Yeah, and if while I'm doing the explanation, you don't understand it, JL, just point your mic and let me know, okay?
Yes, sir.
Angelica, are you there?
Yes, sir.
Okay. Well, I know Johnson there. Deja here. David, Dion. Jada, Lena, Kaleem, you there?
So why you don't rename him?
I did.
Yes, sir.
Okay. Miguel, are you there?
So,
Uh-huh.
I have a question.
Ria.
21 is negative 21 or positive?
21. That's negative. Sorry.
Okay.
So somebody have up their hand.
Yeah, let's see. Nalini, you there?
Yes, sir.
All right. Regan, what about you? You there?
Yes, sir.
Okay. Musa, you there or you not there? Musa. Okay, so we know Musa not there definitely.
Yes, sir, I hear.
Alicia, you there? All right, nice. Okay, so I'm gonna correct now. So remember, JL, if you have any questions, let me know, right? So is the first element here, which is negative 13, take away first element here.
So,
Uh-huh.
can't hear you.
Oh, you hear me good now?
Yeah.
Okay, so it's negative 13, take away negative 3. That will give us the first element. And then 14, take away 6. And then 18, take away negative 21. Sorry if the phone is if the video is jumping a lot because this tripod thing that I have, it's very flexible and every time I shake the table it is shaking. And then of course negative 6 minus negative 14. And if you don't know how to work the signs, you can just use your calculator.
So you put negative instead of negative 21.
Oh, yeah, I was just checking to make sure you were paying attention, and very good, Desha. Only you were paying attention, so I commend you for that. Right? So good job.
You're putting it in the wrong place.
What? What's up? Again, I was just making sure, right?
So that goes fabric, so that goes fabric.
No, sir. You didn't get a break.
Time is only 10 o'clock. We'll get it in an hour.
Exactly, Kaleem. It is only 10 o'clock. Okay, so let's use our calculator if you're having problems, right? So negative 13 take away negative 3 will give us negative 10. And then of course 14 take away 6 will give us 8. And then 18 take away negative 21. This will give us 39. And of course negative 6 take away negative 14. This will give us positive 8. So A minus B is that.
So I got it correct.
Congratulations. Anybody else?
Yes, I get correct.
Yes,
Okay.
sir.
Yeah, I get correct.
Very good.
It's just I made a mistake for the date at the top.
All right, no problem. That's good. So now we are going to move on to let me see if I can make myself the host again. Okay, you all see my screen? Are you all seeing this screen?
Yes, sir.
All right. Just give me a minute, right? Take 2 minutes break before I move on. I just want to do something with the computer. Just 2 minutes, huh? Right. So now we're moving on to the multiplication of matrices, multiplication by a scalar quantity, right? So what does this mean? It just means that you are multiplying everything inside of the matrix by whatever the scalar quantity is. So in other words, it's so right. So a scalar quantity is any positive or negative number. So for example, if A is equal to if A is equal to 4, 5, 3, 9, and we are asked to find 2A, that means that this entire thing here is A. And if we are asked to find 2A, that means we are just multiplying everything inside of here by 2. So this 4 by 2 will give us 8, 5 by 2 will give us 10, 3 by 2 will give us 6, and 9 by 2 will give us 18. So therefore 2A will equal 8, 10, 16, and 8. I just forgot to put the brackets here, right? Yeah, people? So I want you all to try number 2 part B for me and tell me what you all get. Let me just zoom up a little bit. I forgot to put the bracket here again, right? So forgive me for that.
So which one we doing?
You're doing number 2 for me.
Sir,
Yeah?
I could call out my answer.
Now, what's somebody else answer?
Okay, well, I'm gonna try and message you.
Okay. Jenna, can you give me your answer?
So I can see my answer.
Okay, sure, no problem.
I have
Dog, I was going to the answer, dog.
oh, do you think not, Jenna? Do you think?
So I'll send you mine.
Yeah, Jenna, let
So
me
you
hear.
hear me, right?
Yeah?
Okay.
Mom,
At
Mom,
27,
I
9
just sent it
minus
on the
12
phone.
and 15.
Sanjay, turn off your mic. I wasn't hearing you,
I'm
Jenna.
asking my mom how to send it on the phone. I don't know how.
Okay, turn off your mic now. I need to hear Jenna. Yeah, Jenna, let me hear.
I got 27, 9 minus 12 and 15.
Nah, your value is correct, but your sign's wrong.
So I
Okay.
could say mine.
So let me
So,
see.
I got negative 27, 12, negative 6, and negative 15.
Should be negative 9.
it's supposed to be negative 9.
I said negative 9.
Negative 6.
Um,
You said negative 6.
so let me see if I can.
So far now,
Oh, I know seeing is negative 3b. I didn't see
Are you all seeing
negative. I didn't see
my
negative.
you all seeing my recording?
No, I'm not seeing it.
Okay, just now. I don't know why it is happening.
Okay, wait, I can see it.
One moment.
So I can put down my answer.
Right, are you all seeing it now?
Yeah.
Yeah.
Okay, great. So B was 9, negative 4, 3, and 5, and we were asked to find negative 3B. So that means we are multiplying negative 3 by everything in here. Okay? So negative 3 by 9, 9 is 27, so that's negative 27. 3 by 3 is 9, and of course, a negative is negative 9. 3 by 4 is 12, and a negative is a positive. It's positive 12, and a negative 3 by 5 is negative 15. So negative 3b is equal to that. Any questions there?
Nah.
Just asking a mistake. I didn't see the negative 3b. I thought it was 3b alone.
Nah, it's negative 3b. So can I take it off?
Yeah.
All right.
My book have the equalness.
Okay, so let me see if I can take off this video now and go back. Did the video stop?
Yes.
Okay, great. Are you all seeing the handout back again?
Yeah.
Okay. Somebody's audio is on. All right. So now we're going to look at multiplication of two matrices. Now I'll call roll shortly, right? Just to make sure that people are actually online and not lying and say they're online or whatever. And for those who are coming on and cutting off, when I call roll, if they come on after that, they are not present. If they leave or whatever, I'll put them absent. So yeah, I'll call roll just now, okay? So multiplication of two matrices. Two matrices can only be multiplied together if the number of columns in the first matrix is equal to the number of rows second matrix. What do I mean by that? Let's see. So, for example, if the first one is a 2 by 2 matrix and the other one is a 2 by 3 matrix, remember the columns and the rows must be equal. So 3 and 2, they are not the same, so therefore this is not equal. So therefore this matrix cannot be multiplied together. Are there any questions so far?
No,
So
sir.
you can repeat that? You can repeat that?
Sure, no problem. And please make sure and understand this, everybody, because this is the heart of matrices now. This, so what I'm going to teach you on multiplication of two matrices, this comes almost every year for CTS. You'll have to, if you have questions, you need to ask them now, okay? So multiplication of two matrices can only be multiplied if the number of columns and the number of rows in both matrix are equal. So like in this case, you remember it's row by column, row by column. That's the format I gave you at the beginning of the handout, right? Row by column, row by column. So in this case, column is 3 and the row is 2, and 3 and 2 are not the same. So that means that this matrix cannot be multiplied. Let's look at this now. If we were given a 2 by 2 matrix and a 2 by 3 matrix, here we can see that the row and the column is 2. So therefore they can be multiplied. Any questions so far?
No, sir.
Make sure you understand this because too many times in the exam, some students are given a 2 by 3 matrix and a 2 by 3 matrix, and they go spending their entire exam period trying to figure out the two how to multiply these, right? When really and truly they could not have been multiplied. And because these students were not aware of this, they got the question wrong, and of course they would have lost a lot of marks and a lot of time because they would have invested a lot of their time trying to figure out this. You need to understand this. If the row and if the column in the first matrix is not equal to the row in the second matrix, then they cannot be multiplied. In this case, the column and the row are equal, so they could be multiplied. You follow? Any questions? I'm giving you all a minute to take down this, just in this format here. That is in bold, please take it down quickly.
So
Somebody,
So
yeah?
I can't really see it.
Oh, is that better?
Yeah.
Okay. I think if you are using your phones, you can zoom in on your phone too, yeah? Okay, by now you all would have been able to pick it up, yeah? Or some people still writing it down? Okay, so I'm gonna put it on the screen, all right? The video. Are you all seeing the video?
Yes, sir.
No, sir.
No.
Not really.
Yes, sir.
Okay, I seen it now.
Just now, huh? Let's see if I can. What about now? Are you all seeing it now?
No, sir.
Yes, sir.
Now? I'm just trying to make sure everybody gets it. One moment. Right, what about now?
Yes, sir.
Yes, sir.
Okay, great. Thank God. Okay. So let us see the first example here, right? Now I have the format on top here, that's for your multiplication, right? So if I tell you an example 1, if A is equal to 2, 4, 3, 5, and B is equal to 0, 3, 1, 2, I ask you to find A, B. Now, you're not just going to find A, B just like that, right? You need to determine what type of matrix it is. So let's see. The first one, this is a 2 by 2 matrix. Agree? Because there are 2 rows and 2 columns, right? Remember, row by column. This next one is a 2 by 2 matrix as well, which is row by column.
So your audio giving trouble.
Oh, sorry, you hear me now?
Yeah.
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 Yeah. Okay. Right. You hear me now?
Yes.
Okay, great. No feedback.
Elizabeth.
Okay, just now. Right. What about now? Better? Is it better now? You hear me better now?
Yes, sir.
Yes.
Okay.
Sir.
Right. So in this case, you're looking at the column and the row. They are equal, aren't they? 2 and 2. And they equal? So because they are equal now, we know that this matrix could be multiplied. Don't go wasting your time without conducting the test, right? You need to conduct the test first to make sure that they could be multiplied. So the format is the first row, which is this row, by the first column, right? So again, first row multiplied by the first column. Yes? So 2 multiplied by 0, yes, plus 4 multiplied by 3. Just now, let me write it better and bigger. So I'll repeat it again. First row, first column. So first row, which is 2 and 4, multiplied by the first column, so 0 and 3. So it's 2 multiplied by 0 plus 4 multiplied by 3. Any questions there so far?
No, sir.
All right. Next one is the first row again, which is this first row by the second column, right? So first row, second column. So it's 4 by 1 plus 5 by 2. Any questions there? Say now or forever hold your peace.
I'm holding my peace.
Thank you for sharing. Right, next one, second row by first column. So second row, first column. So 3 multiplied by 0 plus 5 multiplied by 3. Next one, second row, second column. So 3 by 1 plus 5 by 2.
So
Yeah?
why is it 5 by 2 on the top?
On the top,
Yeah, the top right.
just now, huh? Oh, sorry. It's 4 by 2, my bad. Yeah, it's second row, first, sorry, second row, second. Wait, just now. This one is, yeah, sorry. It's supposed to be 4. And
And isn't it supposed to be 2 times 1?
okay, just now. I'm confused now. Let me just do it back. Sorry about that.
So wow.
Yeah. Thanks, Regan, for playing with my head a little bit. Thanks. So 2, it's first row by first column. So 2 by 0 plus 4 by 3. And then first row, second column. So 2 by 1 plus 3 by, sorry, no. Sorry, plus 4 by 2. Right, yes, now that's correct. Then second row, first column. So 3 by 0 plus 5 by 3. And then second row, second column. So 3 by 1 plus 5 by 2. Now that is correct. Now, how do you know if you are doing it correct? There's an easy way to recognize that. If you all notice, we have 0, 0, we have 3, 3, 1, 1, 2, 2. Yeah? Yes, people?
Yeah.
Yes, sir.
Yes,
Notice
sir.
0, 3, 1, 2 is 0, 3, 1, 2. Yeah? And if you all look at what remains, let me draw a squiggly line here so you can see the difference. We have 2, 4, 3, 5, 2, 4, 3, 5, and of course 2, 4, 3, 5. Y'all seeing it?
Yeah.
Oh,
Yes,
okay,
sir.
okay.
Yeah. So now that we have established this, we are going now to work it out. 2 by 0 is 0, plus 4 by 3 is 12, 3 by 0 is 0, 5 by 3 is 15, 2 by 1 is 2, plus 4 by 2 is 8, 3 by 1 is 3, plus 5 by 2 is 10. And of course, we can work this out now, right? So 0 plus 12 is 12, 0 plus 15 is 15, 2 plus 8 is 10, and 3 plus 10 is 13. And that's our answer. Are there any questions? Because I don't give
No, it seems I can understand this.
Yes, it seems very easy, yeah, but it's very confusing. Don't worry, when I get one, just now you will see.
Trust me, I know I'm going to do some kind of notations on my book.
No, girl, no doubt yourself.
I like your positivity, sir. I give you props for that.
No problem, no problem. That's what I'm here for. So I'll give
You
you
know
all
you're
two.
phenomenally picking on people now, but thanks.
Is the video better, Brittany, or is it still too small?
Yeah, you could go over this, please.
The entire thing?
Yes.
Okay. I'll do it one more time. So we are asked to find AB. So we have to multiply A by B. And we are given here the format. First row, first column. So the first row multiplied by the first column. So it's 2 by 0 plus 4 by 3. And then first row, second column. So first row again, 2 by 1 plus 4 by 2. Then of course, second row, first column. So 3 by 0 plus 5 by 3. And then second row again, so 3 by 1 plus 5 by 2. Yes, Andre?
Yeah.
And of course, we want to make sure everything lines up. 1, 1, 2, 2, right? And 2 by 0 is 0, plus 4 by 3 is 12. 3 by 0 is 0, plus 5 by 3 is 15. 2 by 1 is 2, plus 4 by 2 is 8. 3 by 1 is 3, plus 5 by 2 is 10. So A, B is 12, 15, 10, 13. And that's it?
Okay, thanks.
No problem. All right, let's move on to our next example now. And I'll give you all 2 questions in this one example. So number 2, if x is equal to negative 3, 4, 5, and negative 1, and y is equal to 2, 3, 6, 5, find x, y, and y, x. So I'm going to give you a total of approximately 10 minutes. So let's correct. Your 10 minutes is up. The first one we want to do is xy. So it's first row by first column, so negative 3 multiplied by 2 plus 5 multiplied by 3. And then, of course, negative 3 by 6 plus 5 by 5. Right? We just double check. Negative 3 by 2, 5 by 3, negative 3 by 6, 5 by 5. Good. Next one, it will be 4 by 2 plus negative 1 by 3. Then 4 by 6 plus negative 1 by 5. I know the light is kind of affecting it there a little bit. So as you can see, we have 2, 2, 3, 3, 6, 6, 5, 5. So we know we're going correct, right? Once you see those repeating elements. So x, y is therefore negative 3 by 2 is negative 6 plus 5 3s are 15. 4 2s are 8 plus negative 1 by 3 is negative 3. So this goes into minus 3. And of course, 3 by 6 is negative 18 plus 25 plus 6, 24. That'll be down minus 5. This will work out to be negative 6 plus 15 is 9. 8 take away 3 is 5. Negative 18 plus 25 is 7. And then 24 take away 5 is 19. So this is our answer. Everybody okay?
So how did you get 5 for the last one?
Oh, I got 5?
X, Y.
I barely
Yeah.
heard you.
8 minus 5.
Okay, just now. I'm on the speaker. My phone is like really low. Just now. I can't hear anything. Right.
You can hear me now, sir?
Yeah.
Okay, so when you was now working out X, Y, like adding up all those on the last one, how did you get multiply by 5? The last one go up. Yeah, those two.
Because remember, it's 4 by 6 and then negative 1 by 5. That's how I get
Oh,
that there.
okay, all right.
Yeah.
Okay, well, I was doing something then.
Okay. Trust me, you just have to practice. These require a lot of practice.
Oh, I didn't
Yeah, it does.
Yeah, once you practice, you will get the hang of it. But the only way you can get it is practicing.
Okay, well, thanks, sir.
Yeah, no problem. Anything. Anybody else have any other questions? No? Okay, I'm moving on then, right? Let's see. Okay, Miranda. Yeah, Miranda, yeah, audio is on.
Yeah.
All right. Yeah, you want to ask something? You understand it?
Yeah.
Okay. So I can do YX now?
Yeah.
Okay, great. So XY and YX are not the same. All right. Let us see here now. I want to find YX. So I think the better thing to do is to rewrite the question. The order in which it is written, that is. That way to make it a lot easier to solve it. So Y, and then we have X here. So Y is 2 6, 3, 5, and then negative 3, 5, 4, negative 1. All right? That's the only way I could see to make it like I'll make my life a little easier. So now it's row by column. So it's 2 by negative 3 plus 6 by 4. Then 2 by 5 plus 6 by negative 1. So 3 by negative 3 plus 5 by 4. And then, of course, 3 by 5 plus 5 by negative 1. Are we looking for a pattern now? Negative 3, 4, 4, 5, 5, negative 1, negative 1. So now y x is equal to 2 by negative 3 is negative 6 plus 24. And this is negative 9 plus 20. 5 is a 10. 6 by negative 1 is minus 6. 3 5 is a 15 minus 5. So yx will be 6, negative 6, sorry, plus 24, which is 18. Negative 9 plus 20, which is 11. 10 take away 6, which is 4. And 15 take away 5, which is 10. How many of us got that? Well, I see Emily now. Emily here. Desha was close.
Yes, sir. I didn't put the negative in the one.
Yeah. Okay, so I see a good few people saying that they got it. All right, great. So when you get the handout itself, there are some practice questions. You can try it at home, right? And of course, the answer is right there. Now I'm going to switch to know this and switch back the handout.
So what time is class finishing?
Class is finishing at 12.
Okay, thanks.
So we getting a break today?
No, Sandy, I'm getting a break. Remember, you're home.
I wanted to go get. I'm kind of hungry.
Just now, you wanted to what?
Go get a snack. I'm kind of hungry.
Oh. Are you all seeing the screen now?
Yes, sir.
Okay, great.
Yeah.
You're seeing the screen and the screen alone, right? No
Yes,
video.
sir.
All right, great. Okay, so this one is called the determinant of a matrix, and it's another important aspect of matrices, and I would suggest that you all master it as well. So a matrix is written in the form A, B, C, D. This is the order of the numbers, right? A, this is where B is, this is where C is, and this is where D is. So to find the determinant, not the determinant, you can write it as a triangle, or you can write it as any letter in the English alphabet with 2 straight lines on the side of it. All right. So anyhow you take it, these are how you could write the determinant. So in this case, I ask you to find the determinant of A. Now the formula is AD minus BC. That's just the formula. You need to memorize the formula. You need to understand the formula because it doesn't change. So for example, if A is equal to 2, 1, negative 1, 2, you're asked to find the determinant of A. So of course, again, you state your formula first. You always state your formula first. So the determinant is this number. Right. The determinant is AD minus BC. And the value for A is 2. So that's why I put 2 here. And remember, multiplication is taking place here. So it's 2 by D. And remember, the value of D is here. So this is D minus B. And this is the value of B, as you can see here, B. So 1. And of course, C is negative 1. So 2 2s are 4. And 1 by -1 is -1, and a negatives are positive. So it comes like saying 2 plus 1, which is 5. So therefore, the determinant is 5. Any questions?
No, sir.
So you can repeat?
From where?
No, just repeat the whole thing.
Okay. So any matrix is written in the form A, D, C, D. So in this case, 2 is A, 1 is B, C, and of course D. The formula is AD minus BC. So AD is 2 by 2 minus 1 by -1. And of course, if this is confusing you can use your calculator. And when your calculator will tell you the answer is 5. And that's it. So the determinant of A is 5.
Oh, okay, thanks, sir.
Yeah, no problem. I hope you're saying thanks and you understand it, and you're just saying that for me to move on, right?
Yeah, don't worry, I understand it.
You're sure, right?
Yes, and if I don't, David like right next to me.
Okay, no problem.
He just keeps at me, yes?
All right. So I want you all to find the determinant of B. And you'll tell me your answers in the chat. Hey, look, Bala, any house boy?
Say that was so random.
Yeah, I'm now going through to see who else come online because I see the list increase. I see Shiva come online too. Hey, Shiva. You all are late. Yes, Shaban, your answer is correct. Yes, Emily, your answer is correct. Sanjay, your answer is totally wrong. Bala, you there? Hawa?
So I know what I do wrong. I know what I do wrong.
No problem.
Hold on a second. Give me a second. I want to do the bucket.
Okay, so let's see.
Hold on.
You all got that? Yeah, Shushmita, correct?
Yes, sir. We got that.
Oh,
Right, so AD.
Sir, just now, wait. I'm gonna add it up now. Okay, I'm good.
We get 7. So AD A is 4 and D is -2, which will give us -8, of course, minus BC. B is -3 and C is of course 5. Negative and negative is a positive, and 5 3 is a 15, so -8 plus 15 is 7. So the determinant is therefore 7. Yeah. Now you see this type of matrix as a singular matrix. All you need to know what is a singular matrix, right? Because in the past papers, I have seen they ask students to determine if the matrix is a singular, or they will tell you that the matrix is singular and therefore determine so on, so on, so. And some students, because they do not know what is a singular matrix, they have a lot of issues solving the matrix question. So in my handout, this handout I have here, it has every single thing that you will need to know about matrices. I didn't leave out a single thing. This handout is really good. It's better than the one that you'll have on FastPass and whatnot. And I didn't leave out anything. So for example, this one is a singular matrix, and it says a singular matrix is one which the determinant is always equal to 0. So when you work on the determinant, you won't be getting things like 5 and 7. You will get something like 0. So again, you need to commit this to memory. A singular matrix is a matrix in which the determinant is equal to 0. Now, this here is called, well, this here is the inverse of a matrix. I'm going to give you all 5 minutes to write down this. So inverse of a matrix, you need to write down everything and the steps as well. Yeah. So I'm giving you all 5 minutes to do that. Hey Lena, I'm using both my phone and my laptop right now, so I'll send it out right after class if that's okay. Both of my devices are being used right now, so. And well, yeah, no problem. I'm turning off my audio. I'm going to get something to eat, right? I'll be back in like 3 minutes. So if you are asking any questions, I will not be here right now. I'm giving you all the time to write on the question. Sorry,
so you're here.
the note.
So you're here now.
Yeah.
So you just want us to write down the info, that one line, or on the steps too?
Yeah. The heading, this one line, and the steps.
That's the same formula I have in my book from high school.
There is man on
Oh, you guys have it?
Okay, so I'm gonna start a question, right? This is a question here. I'm gonna put it on the I'm gonna put on my camera. I also see the whiteboard.
Yes, sir.
Everybody's seeing it, right?
Yeah.
Yes, sir.
All right, great. So I want you all to follow these steps that I just gave you all there, and we are going to work out the determinant of a matrix. So we are asked here, we are given that A is equal 3, 4, 1, 2, and they're asking us to find the inverse. Okay, so the first step in finding the inverse is finding the determinant. So the determinant of A is equal to A B minus B C. That is the formula. So remember, it was A B C D. Yeah, I put it in red. So it's A, which is 3, D, which is 2, minus B, which is 4, and C, which is 1. So 3 plus 6 minus 4, this will give us 2. So the determinant of A is 2. That's step 1 completed. Step 2, they said interchange the elements in the diagonal. So let's just write back what A is. 3, 4, 1, 2. And remember, they are telling us to interchange the elements in the diagonal. And remember, I told you all the diagonal runs from bottom right, bottom left, top left to bottom right. So this here is the diagonal, not this way, okay? It's this way. So we write back 4, 1, and then we change the element in the diagonal to 2, 3. That's all so far. Step 3 says to change the sign in the other elements. So we write it back 2, 3, 1, 4. So the other elements will be the elements that is not in the diagonal, which is this 4 and this 1. So it's negative. Let me just do it in one step here. Right? We're changing the signs in the other one. So it's negative, negative. Of course, if this was positive, negative, it'll turn to positive, right? So that's that step. And the next step, which is the fourth step, the last step, is to multiply the new matrix, which is this. So our new matrix is 2, negative 1, -4, and 3. We have to multiply that now by 1 over AD minus BC, which is basically the determinant. So in this case, the determinant is 2. So it's a half multiplied by everything, and this here is the answer. Now we could take it a step further and say a half multiplied by 2, because remember this is the scalar quantity. Remember I told you what is a scalar quantity when we have something multiplied by everything inside of here. And if that was the case, it would have been 2 over 2, which is 1, -1 over 2, -4 over 2, and then 3 over 2. And we can break this down further. 2 into 2, 1, so we got 1 here, -1/2. This will give us -2, and then 3 over 2. Any questions so far? This is the final answer.
So you could do that over.
You holding?
Yeah.
Or just after?
Yes. From interchange the elements.
Okay, sure, not a problem. So everybody's supposed to know how to get the determinant, right? Everybody okay with this so far? Or everybody want me to do that?
No, we good.
Okay, no problem. So the second step is to interchange the elements in the diagonal. So let's write back what the elements are. 3, 4, 1, 2. So we are interchanging the elements in the diagonal now. Only the diagonal. So instead of writing 3 and 2, we will now be writing 2 and 3. The third step says to change the sign of the other element. So this is positive, so it becomes negative. And then the final step, it says to multiply 1 over the determinant, which is 2, by the new matrix, which is 2, -1, -4, 3. And of course, this is multiplied by everything in there. So a half, if you take the calculator and say a half, multiplied by 2, which will give us 1. Yeah. Let me write it back. And then you could say -4 multiplied by a half, or a half over a half multiplied by -4, you get -2 and so forth, right? So let me just do it in great detail. -4 by 2, -1 over 2, 3 over 2. So our final answer will be 1, 4, -1/2, 3 over 2. Any questions on that?
Possible to be -2.
Did you see that?
And if possible would be -2.
Oh, shucks. Yeah. Sorry. I was just checking to make sure I always do this in between. So thank you very much for pointing that out.
Welcome.
Yeah, no problem. I knew that already, yeah. So it will feel nice, I of course I knew that. I always know these things.
Okay, sir.
Yeah.
Wait.
Uh-huh.
I don't know.
Yeah, we can get rid of it.
Can I erase it now?
Yes, sir.
Okay, so I'm going to give you all one to try, right? If B is equal to 3, -2, 7, -8, find B inverse. That's the next way to write B inverse, right? Instead of writing all the word inverse, you write B to the power of -1. So I'm going to pause the recording, and I will start back the recording as soon as we start it correct, right? So somebody can just remind me to press play in the recording, okay? Yeah, I'm recording. Okay, so the first step is to find the determinant. So it's A E minus BC, right? And of course, we have A, B, C, D. So A, which is 3, D, which is -8, minus B, which is 7, and C, which is -2. So 3 is a 24, that's -24. And a negative is a positive 7, which is a 14. So when the times are different, to find the difference, just 10, and keep it finding greater number. So the determinant is -10. Yeah? The next step is to interchange the elements in the diagonal. So the current element is 3, -2, 7, -8. So when we interchange the elements in the diagonal, we'll get -8, and of course 3, and of course we get 7, and this will now, and then we have -2, right? But remember, we have to change the sign. So this will be positive, sorry, this is positive 7, this will now become -7, and this is -2, so this will now become +2, right? And remember, it's 1 over the determinant, which is in this case -10, multiplied by everything inside of here, so it's -8, 2, -7, 3. So we can multiply everything in here by the new determinant, sorry, by the determinant. So it's -8 over -10, 2 over -10, -7 over -10, and 3 over -10. And of course, certain things can cancel off. So the signs here can cancel. 2 into 8, 4, 2 into 10, 5. So we can get positive 4 over 5. Here we can get 2 into 1, 2 into 10, 5. So -1 over 5. And of course, the negative here to cancel off. So you get 7 over 10. And then 3 over -10. And that's it. How many of you got that?
Me.
Me.
Okay, great. I will leave it up for a minute, and then I'll take it off. Okay, I'm gonna take it off now. Okay, let me just explain something quickly. If we have a matrix, let's say we call it A, and we multiply it. Now in math, you can write multiplication by writing on top, or you can just write the multiplication sign. If we multiply it by its inverse, we will get the identity matrix. right? So for example, with the one that we had before, the question we had before, if we want to multiply the original matrix by what we found, which is the identity matrix, sorry, the inverse, we will get the identity. And an identity matrix is a matrix where the elements in diagonal is 1 and everything else is 0. You remember that? I see you have, so we have some new people that join here. Those of you that missed the morning, well, missed the majority of the handout, the session is being recorded. So you all can, when Lyndon upload it on YouTube, you can check for it and you can just pick up where you left off, right? Because matrices is a very important topic. It comes every year and it's an easy topic to get marks, get easy marks with, right? And you can't get away from it because it's going to come in the multiple choice as well. But in this case, we have only multiple choice exam, but it's going to come, right? And you have to know what to do. And I also explained the new format of the exam this morning, so you all could replay it when Linda uploads it to get a better idea. Okay, let's get started then. So if I tell you that A is equal to 2, 0, 1, 1, and I ask you to find A inverse and prove that A multiplied by A inverse is equal to the identity. This is how you're going to do it, okay? Now this is going to be a little lengthy, right? So I'll try my best to take my time. So we first have to find the inverse. And we know how to do that. The first step in finding the inverse is finding the determinant. So the determinant of A is equal to AD minus BC. And of course, we label A, B, C, D to make life easier. So A is 2, B is 1, minus B, which is 1, into C, which is 0. So 2 by 1 is 2, minus 1. 1 by 0 is 0. So 2 minus 0 is 2. So the determinant is 2. And now, remember, we have to interchange the elements. So the current matrix is 2, 0, 1, 1. So we have to interchange the elements in diagonal. So here will now become 1 and here will now become 2. This is the diagonal here, right? So we have to interchange the elements, that's the rules. And of course, we change the sign. 0 is neither positive nor negative. So the one we put on negative 0 there. If I see anybody write a negative 0 in the exam, I'll come to this and bust on their head. And that's a joke, by the way. So,
Sounds serious too.
Huh?
Sounded pretty serious.
I'm not sure that's not.
Negative 0.
Huh?
Yes, my mom hear you chatting now.
Very funny.
0 is a neutral number.
Yeah, 0 is neither positive nor negative. So you don't put negative 0 or positive 0. Okay?
I might put negative or positive 0.
Huh?
I might put negative or positive 0.
You might put that?
Yes.
Because this session is being recorded, and you never have to tell if parents are wrong. Try it now.
Okay, sir.
So 1, in this case, positive, and remember to change the sign to become negative 1. All right? So it's 1 over the determinant now. 1 over 2 multiplied by the new matrix. 1, 0, negative 1, and 2. Everybody okay so far?
Sir,
I
heard absolutely nothing what you just said.
From where?
From like before you said everybody everybody understand.
Okay, from underneath the red line, you understand it? I mean, you hear from up here, right?
No.
What?
Wait, yeah.
Okay.
Yeah.
So,
yes.
Right, so that's from here I have to repeat, right?
Yeah.
Okay, great. So this comes from finding putting the inverse.
Oh my God, it's doing it again. Like I hear you, but it's really muffled.
Oh. What about now? You hear me now?
Nope. I hear you say now, but still really muffled.
Okay, hold on.
So it's like he had sprinkled toilet water on his mic.
Right. What about now?
No, sir, it's still
What about now? Now?
Kind
barely.
of. Yes.
Okay,
I
just
can't
now.
decide.
This audio thing is killing me right now. I need to put on a speaker to my phone to hear all you. Right. All you hear me now?
Yes, sir.
Oh, yes,
All
sir.
you hear me?
But actually, sir,
Yes, sir, I hear you.
right, type out what write out what was writing because I want to see if we're doing it again.
Okay. So I'm gonna
Okay.
yeah, I forgot this step as well. No. Right. So when you find the determinant, you have to interchange the elements. So 2, 1, 0, 1 is the current element, right? You have to interchange the elements in the diagonal. So this becomes 1, 2, and you change the sign of the other remaining one. So this becomes -1. You don't change the sign of 0 because 0 is neither positive nor negative. So now the next step is 1 over the determinant, which is 2, by the new matrix, right? And of course, this will give us, remember we have to multiply this by everything inside. But it's this, the old matrix multiplied by the new inverse will try to give us the identity. So if we were to multiply this half by everything in here, we will get fractions, right? Now you could use the fractions, but I honestly think it's easier to just multiply this by the old matrix and then put in the half after. Or you all want to do the half now, you want to get in the final step now and then take that final step and multiply by the old one. Which one do you prefer?
The best one.
All right. But because I don't want to confuse anybody, I will do it how I showed you all to do it at the beginning. So let's see. It's 1 multiplied by half, which is a half, and then this will give us 0, negative a half, and of course 2. Yeah, let me not do it this way because this will confuse all you. So when you reach over here, all you do is you take the new, this is the new matrix, right? By the determinant, and you multiply by the old one. So 2, 0, 1, 1. Anybody confused about what I just did? All I did was add this here.
No.
No, right? And forget that this half exists for now. Forget it exists. Now, remember how we were multiplying the matrix before with the formula? Do you remember that? Hello? Do you remember that?
Yes, sir.
Yeah.
The formula is the first row by the first column.
First row by first row.
First row, second column. Then second row, second row, second column. Remember this? Yes.
Yeah.
So the first row, so it's 1 by 2 plus -1 by 0. And then first row, second column. So it's 1 by 1 plus -1 by 1. And then it's second row, first column. So it's 0 by 2 plus 2 by 0. And then, of course, it's second row, second column. So it's 0 by 1 plus 2 by 1. Yeah? So let's work out and see what we get here. I'm just going to transfer it up here. So 1 by 2 is how much? 2 plus, well, this will give us 0. So 2 plus 0 is 0. 0 by 2 plus 0 by 2, that gives us 0 as well. 1, this will give us 1 by 1 is 1 plus -1 by -1 is -1. So this will give us 1 minus 1. And of course, 0 by 1 is 0 plus 2 by 1 is 2. So this leaves us with 2, 0, 0, 2. Not so? Yeah? I'm trying to get rid of the glare from the light. Anybody confused so far?
No, sir.
All right. So now we bring back the half. Now we can put back this determinant here. So it's 1 over 2. And now we can multiply this half by everything in here. So 2 over 2, 0 over 2 is just 0, 0, and then 2 over 2 is that. So this will give us 1, 0, 0, 1. And then this is the identity, and the identity is 1, 0, 0, 1. Remember, we did that in the handout. So, and we just prove it.
Yes, sir.
Okay. Can I give you all a minute to take it, and I'll give you all one to try? Tell me when you all are finished taking it down, right?
I'm done, sir.
All right.
So don't take it off.
What was that?
Don't take it off as yet.
Okay. So basically what we did was prove that E multiplied by its inverse, because this is E and this is the inverse, will give us the identity, which is 1, 0, 0, 1. Right, so I'm taking it off now. I'm going to give you all one to try. If E is equal to 1, 4, 2, 3, find E inverse and prove that E multiplied by A inverse is equal to the identity. I'll give you all 5 minutes to do this one, to try it, I'm gonna pause the recording, and somebody just remind me to press play when I'm going to do the working. Okay, time to do this. Anybody finished with it and got an answer they wish to share? Well, not wish to share. We all supposed to get the answer, but
I got the answer.
anybody, you got it? All right. So let's see now. The first thing we want to do is find the determinant. So the determinant, state the formula is equal to AD minus BC. And from here we can see that this is A, B, C, D. So AD is 1 by 3 minus B, which is 2 by 4, which is C. So 3 minus, what is that, 8? The answer is minus 5 or negative 5 as the determinant, right? And remember now we have to find the new matrix. So it's 1, 3, 4, 2. So we interchange the elements in the diagonal. So this becomes 3 and 1, and this becomes negative 4 and negative 2, right? The rule says you interchange the elements in the diagonal, you change the sign of the remaining elements, right? And now we multiply the determinant by this here. So 3, negative 4, negative 2, and 1. But before we do that, you want to put back your old matrix, which is 1, 4, 2, 3. And let's multiply it out. So it's first row by first column. So it's 3 by 1 plus negative 2 by 4. Make us write this a little smaller. So 3 by 1 plus negative 2 by 4. And then, of course, 3 by 2 plus negative 2 by 3. And then, of course, negative 4 by 1 plus 1 by 4. And then negative 4 by 2 plus 1 by 3. Let's look for a pattern. 1, 1, 4, 4, 2, 2, 3, 3. So because of our pattern there, we know we're going correct. So let's see. 3 by 1 is 3 plus 2 by 4 is negative 8. 4 by 1 is negative 4 plus 4. 3 by 2 is 6 minus 6. 4 2 is a negative 8 plus 3. So let's simplify this further. 3 take away 8 will give us negative 5. This will give us 0, 0, and of course negative 5. Now we can bring in our determinant here, 1 over negative 5 multiplied by negative 5, 0, 0, negative 5. Right? So this will work out to be negative 5 over negative 5, 0, 0, negative 5 over negative 5, which will be, this will cancel with each other. You get 1, 0, 0, 1. And this is the identity. So we just prove it. You all got that?
Yes, sir.
Yeah.
All right. I'll give you all a minute to just take it in. And then we're going to start the final thing for today, which is solving simultaneous equations by the inverse matrix. And we had one more, and we had something to finish off last day. What topic we was doing last day? Relations and functions.
Yeah, Emily forgot to remind you.
Yeah, Emily, thanks a lot, right?
Don't see.
Actually, so we told you the first part, and you said you're teaching a new topic because everybody was together.
Yeah, but I had to continue the relations and functions. Everybody would have done that.
Yeah, but I tell you that, but you didn't. You said what you said. So
No, I tell you, as soon as class start, remind me. You see, I will beat you now.
Yes.
Yo, beat me.
Mr. Gunada, I reminded you this morning.
Oh God, you see, I forget. I didn't even hear that.
And then you said, okay, we were doing a new topic because we had the whole, all 3 classes together.
Oh, huh. Well, I didn't even remember that. Oh God, you see my brain all over the place.
When you play back the recording, you'll hear it now.
All right. Well, I apologize then. Emily, I'll still beat you.
Permission granted.
What?
Why every parent give teachers permission to beat their child? Why?
Because she deserves it.
Okay, so let me just finish off simultaneous equation matrices, and I will do I studied how to fit in this relations and functions because that was supposed to be done this morning, and I totally forgot that I had to do that. So here's what. In our next class, which will be sometime this week, I will finish off the relations and functions as well as matrices, and we will do in the next class. We'll just be doing past paper practice as well. So that's a class you don't want to miss. That will be an intense class where we will be doing past paper questions on matrices, and we'll be finishing off relations and functions, and we will also be doing past papers on that, including multiple choice practice. Okay, and I apologize for not starting with the relations and functions because I know that was the last thing we were doing. So can I take it off?
Yes.
All right. If I'm finished with simultaneous equation matrices, then I could do the continuation of the relations and functions quickly before class ends. There's not much again me out.
So we finished in class quarter. So 12 or on 12 on that.
No, on 12 on dot.
You say you don't have that much time.
True. Well, I'm gonna rush anything then. So let me just finish off matrices, and then we will end class. And next class I'll start off with relations and functions, the continuation, and we'll do past papers. So let me write that down because I will forget that.
Take your count on me to remind you.
Huh?
You can count on me to remind you, yeah.
All right. Relations and functions.
So write it down in your phone.
Nah, I just write one thing in my phone and I will check it. Relations and functions, then do past paper questions on it, and great. Leaving this on this table. All right. So you're given a question, a simultaneous equation question, and you are expected to solve it. So let me look for a question. Suppose you are given 5x plus y is equal to 11 and 3x plus 2y is equal to 8. This is a pair of simultaneous equation, and if they ask you to solve it using the matrix method, you need to know how to do that, right? So the first thing you want to do is pull out the values. So you could open your matrix. The first one is 5, then 3. This is a 1 is understood in front of you, y, and then of course 2. Everybody okay with that step? That's the easiest step.
Sorry,
Sure. Let's say you were given 5x plus y is equal to 11 and 3x plus 2y equal 8. And you are asked to write this, to solve this using the matrix method. You guys taking all the values. 1 is understood in front of that y, and you have 3 and 2. So in your brackets, you will have 5, 3, 1, 2. Yeah?
Oh, okay, thanks.
No problem. And remember with simultaneous equations, you are finding for x and y. So in the next pair of brackets, you're going to put x, y is equal to 11, 8. That's all so far. Everybody okay? Okay. So the first step is finding the determinant. So A, D minus B, C. This is A, B, C, D. So it's 5 by D, which is 2, minus B, which is 1, C, which is 3. 5 2s are 10, minus 3, which is 7. Nobody confused there, right? So we want to find for x and y. So we can simply write x, y is equal to, and we want to take this and put it across here. So 5, 3, 1, 2, and then we have 11, 8. But of course, the determinant is added onto this. It's 1 over the determinant, right? Everybody okay with that so far?
Yes, sir.
Yes,
All right.
sir.
So let's determine if this can be multiplied. This is a 2 by 2, and this is a row which is 2 by 1. So as you can see, they are the same. So because they are the same, this could be multiplied. All right. So let's multiply it. So it's row, it's 5 by 11 plus 1 by 8. 5 by 11 plus 1 by 8, and then that's it there. And of course, 3 by 11 plus 1 by, sorry, plus 2 by 8. Let's look at our pattern. 11, 11, 8, 8. So 5 by 11 is 55 plus 1 by 8 is 8. 3 by 11 is 33 plus 2 by 8 is 16. And of course, it's 1 over 7. 1 over 7 by all of that. So 55 plus 8 is how much? 63.
63. 63, sir.
Sanjay heard you.
Yeah, I heard you, Sanjay. 63. And then, of course,
My question.
33 plus 16 is 49.
49.
Yeah. So, just a minute. 1 over 7. So, of course, when you multiply it by this, you will get 63 divided by 7 is 9.
Is
And
9.
of course, 7. So this is x, y. So that means that x is equal to 9 and y is equal to 7. And that's it. X is 9, y is 7. Any questions?
No, sir.
Okay, so if there are no questions, then I think it's safe for us to end class.
Okay, bye. I'm just joking.
All right. So next class, we start off again with relations and functions. We're going to do past paper questions on it, and we're going to do matrices, right? So goodbye. I shall see you all here again sometime soon. So the Wednesday people have class on Wednesday. The people from Monday, you all don't have anyone. You all don't have any class tomorrow. So you all will have a makeup class. So Wednesday people, you all have class Wednesday. Saturday people, you all have class Saturday. Then we have class again on next week Sunday. Every Sunday for the month of April, we have class on a Sunday. And of course,
so what are you teaching in the Wednesday class?
Well, in the Wednesday class, I'm going to be it'll be a continuation of today's class. So
Okay.
every other class from now on, for this week, we'll be doing relations and functions, and then past papers on relations and functions and matrices.
Okay, cool.
Yeah.
What
Okay.
time is your Wednesday class?
From 5 to 8.
You can send us the login.
It's the same thing. The same thing.
Oh, okay, cool.
Yeah. Okay. Goodbye.